So this one, let's see. If I give you this question, I can give you this diagram or something similar to it, and then it's just a regular old chi question, but you get to look right off of this diagram, if I can line this up properly. There we go. Okay, so for example, the cube, this is, for example, B in the diagram. Shape used is square, or I don't care if you just want to draw it like this, that's fine with me. Icosahedron is a triangle and it's D. Tetrahedron is shape A. It's a triangle. Dodecahedron is, I think that's an E. It's a pentagon. Doesn't have to be a nice one. Octahedron is another triangle. The octahedron is shape. Oh yeah, I can't actually read those letters. Okay, so this one is the dodecahedron, this is the icosahedron, this is the tetrahedron, this is the cube, and this is the icosahedron. Whoops, sorry, the octahedron. So, number of faces in the dodecahedron. Well, the number of faces matches the Greek part of the name. Dodeca is 12. Tetra is 4. Icosa is 20. Cube, I mean, I don't know what we call this. It doesn't have a prefix, but we all know what the cube has, you know, front, back, right, left, up, down. If you don't know that after solving them, then we have a little bit of a problem. So, it's a little harder to count edges. Tetrahedron, you can just trace it. I would recommend bringing a pencil to the exam in case you want to go 1, 2, 3, 4, 5, 6. Okay, we have 6 of those. Okay, and then what? We have how many vertices? 1, 2, 3, 4. 4 of these. All these are going to be 1s. Alright, so that guy's done. Tetrahedron, except I'm an idiot because I just put those under dodecahedron instead of tetrahedron. There we go. That helps. And we should make sure that chi is the same for all these. So we have 8 minus 7 is 1. These should all be 1s. Okay, number of edges in the actual dodecahedron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. See, that wasn't so bad. A little easier to count them on paper than it is to count them in real life because they aren't moving on you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's not my fault if you can't see them. This diagram is about as good as it's going to get. But yes, there's 2 vertices here and 2 vertices here that are close to each other. You have to know that chi is going to be 1 for all these objects, so if it doesn't add up, then you counted something wrong. Icosahedron, we have 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, plus something. So I'm going to erase all this now. I'm going to count the gray ones. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Yep. And how many vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's that. That wasn't so bad. And then the cube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You should be able to figure that out. Vertices, there should be 8. Octahedron, edges, 4 on the top, 4 on the bottom, 4 on the side, so that's 12. And there should be a total of 8 faces and 8 vertices. Yep. So just double check that all the addition works out. And the other thing is that the tetrahedron is its own self-dual. And then the dodecahedron and the icosahedron are each other's duals. I'm sorry, there's not much space here. I'll try to fix that on the exam. Octahedron and the cube are each other's duals. And what does it mean to be a dual? Well, that means it's a good thing I asked that question, because notice this should be a 6, or something else might be wrong. I suspect this is what's wrong, because in the dual you expect those guys to be reversed of each other. Octahedron should have 6 vertices. Yes, octahedron actually has 6 vertices. Whoops, I miscounted. So there we go. Because I put the question in who's the dual of the other one, then you find your error. That was totally not intentional. So tetrahedron, this number has to match this number because it's its own dual. The number of faces and vertices has to be the same. Whereas this 12 is going to be the same as this 12, and this 20 is going to be the same as that 20. Because again, they're each other's duals. So it's the faces and the vertices are going to match each other. Does that make sense? So again, the dual, if it's a dual, in this context, this number matches this number matches this number, then these guys are each other's duals. Alright, yep, hopefully that is helpful. That would be full credit. Try not to scribble quite as much as I did.